Okay, so today we want to start looking at some different ways we can count some items up. All right, and we're not looking at this as counting, as in counting numbers. Okay, now what we're wanting to look at now is how we can count different combinations, or we can count up large numbers of how many different types of combinations we can generate. Okay, so for example, here we got my little makeshift spinner and we got a standard game cube. We may ask you the question, okay, how many different color and number combinations can we get from these two items? All right, and the goal is for you to be able to come up with that number. How can we come up with number color combinations? We have three different scenarios that you can do. Okay, scenario number one is you can just make yourself a list. You can just make yourself a list. Red 1, red 2, red 3, red 4, red 5, red 6, blue 1 through blue 6, green 1 through green 6, yellow 1 through yellow 6. Okay, so one way to answer these types of questions is just to generate a long list. Try to be organized about that list. Okay, it will save you some time, but we can see 6 different reds plus 6 different blues plus 6 different greens plus 6 different yellows leaves us with a grand total of 24 different combinations. So that's one way to organize this problem so we can keep track. All right, the second approach is that we sometimes ask you to make tree diagrams. All right, and again, a tree diagram is nothing more than another way to organize these things. Okay, so like with all trees, you start with your seed. Okay, start with your seed. And then as we start to grow, we need a branch for the red. We need a branch for the blue. We need a branch for the green. And we need a branch for the yellow. Okay, so that's our first year growth. Second year growth is all going to be numbers. So coming off the red, we need a branch for 1, a branch for 2, a branch for 3, 4, 5, and 6. Branch for 1, branch for 2, branch for 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so once you complete your tree diagram, we're looking for the final year. How many branches on the final year? 6 plus 6 plus 6 plus 6. We end up with 24 again. So the first two approaches, organized list, some sort of a tree diagram, that will give you an idea, give you a visual so you can get all those items partnered up, paired together, and then you can get an accurate count of what you need. Not one is preferred over the other. We just need to make sure we read the directions and use the one that they're asking us to do. Sometimes we ask for this, make a list. Sometimes we'll ask for a tree diagram. And then obviously, we're always looking for the super duper shortcut. And all we have to do here is apply our counting principle. Okay, if we want to count up combinations, the counting principle says all we need to do is multiply our parts together. So if we look at our parts, we got 4 colors. So 4 colors times 6 numbers. 24 combinations. 24 combinations. This is nice if we're not required to show any work. This is nice if we don't have to go through and find a particular item. So, if we're just looking for a number, the counting principle comes in handy. It's nice sometimes to have these visuals. We may go back and say, oh, okay, we could ask how many different combinations do we have that involve the number 1? Well, if we have a nice list, we've got a nice visual, we can see that there's 4 right there in front of us. So these are also beneficial if we are asked to find specific combinations. This is great if we're just looking for that total. Okay? So those are some basic ones. We also like to increase this, all right, to some bigger counting situations. For example, how many different kinds of phone numbers can we have in Hocking County? All right, so we all know the first 3 digits of our phone numbers are going to be 385. That's pretty much standard. Don't have to worry about that. So the question wants to know how many different phone numbers do we have? Well, we need those last 4 numbers. So a nice way for us to count, obviously we could generate a list. Going to be a big list. Obviously we could make a tree. Going to be a huge tree. So again, neither one of those approaches is going to be the best approach to this problem. The counting principle says we can multiply our parts up if we know how many parts we have. So that's going to be the best approach here. So what we need to figure out is how many different numbers can go in this first spot. Well, if it's a phone number, 0 through 9. That means we got 10 digits. How many can go in the second spot? Again, 0 through 9, because if it's a phone number, you're allowed to repeat digits. So there's another 10. There's another 10. There's another 10. Now we know our parts. Now the counting principle says just multiply your parts together. 10,000 different phone numbers with the 385 in Hocking County. 10,000 phone numbers. And that's definitely a situation where we want to use our counting principle, because the other 2 extremes, nobody wants to make a list or a tree with 10,000 items in it. We wouldn't expect you to do that. So 3 different approaches to your counting situations tonight. Do the best you can, and as always, bring any questions to class tomorrow. Have a good night.